Hi class, we are now starting on chapter 5. This is molecules and compounds. So we're going to start off first understanding that most of the substances we encounter in everyday life are compounds. They're not elements. There are very few elements that are found by themselves in nature. So most of the things that we come in contact with are a mixture of elements in a specific ratio, so definite proportions. So when I talk about that, I mean like water, something that has H2O. If it is pure water, no matter where it is found in the world, it always has 2 hydrogens and 1 oxygen. So that's what a compound is in fixed definite proportions, In a mixture, so that's the difference. A compound has fixed definite proportions. Think of water, H2O, always H2O. In a mixture, the proportions are whatever they are. If you go to the beach and you pick up sand, you will see a bunch of different particles in there. Somebody else can pick up particles and right next to you, and they will have a different proportion of all those same particles. That's a mixture. It's not it's whatever it is at that moment. So elements, combined fixed definite proportions. A mixture, again, is a balloon. Here's an example of a mixture of hydrogen and oxygen gas. The relative amounts of hydrogen and oxygen are variable because you can add them to a balloon and to another balloon and another balloon, and the ratios may not always be the same. You may have way more hydrogen in one and way more oxygen in the other. A chemical compound, however, if I fill it with water, it is always H2O. We're not looking at the amount of water in the balloon, but what makes up that compound, and that compound is 2 hydrogens and 1 water and oxygen in a fixed ratio of 2 to 1. So Joseph Proust came up with an idea that elements combined in fixed proportions to form compounds. This is known as the law of constant composition. All samples of a given compound, now compounds are not the same as mixtures, have the same proportions. So for instance, water is H2O. Hydrogen peroxide is always H2O2. So you could determine whether you had hydrogen peroxide or water based on if you can get through experiments and calculations determine the mass ratio, because water will always have a ratio of 8 to 1. Oxygen to hydrogen, when you're looking at the mass, this is a mass ratio, where hydrogen peroxide will not have a ratio of 8 to 1 when you're dealing with the mass. So this is a way to help you determine what you're actually working with. So if we decompose 18 grams of sample of water, if you add the water together, oxygen 16, hydrogen is 1.008 times 2, it's approximately 2, so that's where the 18 comes from. And if we break this down into mass ratio, the key being mass, so the mass, that's why we're dealing with grams on this. If oxygen's on top, it's more than the hydrogen, the mass is. So we have 16 to 2. This gives us a ratio of 8 to 1. So what this means is that there is a ratio of 8 to 1, oxygen being with 8, hydrogen being 1. It's not necessarily, we're not looking at the moles of the coefficients, we're only dealing with mass ratio here. So when we break this down, this is what the mass means, 8 to 1. So if we look at another compound we think is water and we're dealing with mass, if we can fit it into the ratio, if it doesn't match 8 to 1, it's not water. And even if it is 8 to 1, that doesn't necessarily mean it is water. We would have to do more research. So you decompose 17 grams of ammonia, which is NH3. A compound composed of nitrogen and hydrogen. We would get 14 grams of nitrogen and 3 grams of hydrogen. 14 for nitrogen and 3 grams of hydrogen. That means 3 hydrogens. So because you think approximately 1 gram for 1 hydrogen atom. So we want to know what the nitrogen to hydrogen mass ratio. Again, nitrogen is more, so it's going to go on the top. Hydrogen is at the bottom. Even though there's more hydrogen atoms, by mass, nitrogen has a larger value. So when we plug this in, we get a ratio of 4.7. This is in relation to nitrogen. So a ratio of 4.7 to 1. So you have nitrogen is 4.7, hydrogen is 1. Now, this is when a compound comes together, it's whole number ratios. But when we look at the masses, the mass ratios, they're not necessarily whole numbers, as you can see here. This is 4.7 to 1. Oops, I jumped ahead. A compound composed of 2 elements, A and B, has a ratio of mass A over mass B. and the mass ratio number is 3. So decomposition of this compound produces 9 grams of element A. What mass of element B is produced? This is a very simple problem. The larger value is going to go on top, and that's A, and then you would substitute mass B as X, and then just solve for X. So if you do that, what you can see here, then we can plug it back in to make sure. B is must be 3 grams. So it's C. Mass B. Let me say that more. Mass B, the answer is C. And that's it.